My dear students, so far we have seen nearly 24 videos in the chapter matrices. I have completed the chapter matrices from these 24 videos. Now I am going to start the next new chapter in this video. The chapter is fourth chapter, Determinants. We have completed the third chapter, matrices. Now I am going to start the new topic, chapter number 4, Determinants. Determinants. These determinants are closely related to the topic matrices. Every square matrix can be expressed as a determinant. The topic determinant is much used in the engineering fields and science and technology. In the area of economics also, we have used the idea of determinants. Okay. Now, any square matrix can be converted into a determinant. Any square matrix is associated with a determinant. The square matrix A is associated with a real number. It may be definition of determinant. Any square matrix A is associated with any square matrix A is associated with a number. Associated with a number, it may be real or complex. Any square matrix A is associated with a number, it may be real or complex, is called a determinant. Called a determinant. A determinant called determinant of the matrix A. Called the determinant of the matrix A. Any square matrix of order 3 by 3, 2 by 2, n, whatever it may be, it is associated with a number, it may be real or complex number, is called a determinant of the matrix A. It is denoted by determinant A or DET of determinant of E. It is written as, it is right in between the two vertical lines, determinant A or determinant of E. So for example, A is a square matrix of order 2 by 2, 2, 1, 3, 4. It's a square matrix of order 2 by 2. It is associated with a real number and it should be replaced as a determinant A. This matrix symbol is in square bracket, is expressed in between two vertical lines. That is the notation of the determinant. 2, 1, 3, 4. This is the notation of the determinant. The square bracket is replaced as two vertical lines. And this is called a determinant. We can associate this determinant with a real number. How? You just multiply the diagonal elements, principal diagonal elements. 2 4 are 8 minus, you should write. Before multiplying the second diagonal element, you just write minus. 3 1 is 3. So 8 minus 3 is 5. Therefore, the determinant value of the square matrix A is 5. This matrix is associated with the real number 5. And this is called the determinant value of A. And this is an example of a 2 by 2 matrix is converted into a determinant and its value is a number. And one more example I am going to give. suppose A is a matrix of order 2, that is A, B, C, D, and this is expressed as a determinant A is in between the two vertical lines A, B, C, D, and this is multiplication AD minus BC. This is the value of the determinant A. In general, any 2 by 2 matrix of the form A11, A12, A21, A22. This is a determinant of order 2. Determinant of a matrix of order 2. It should be expressed as A11, A22 minus A21, A12. This is an expansion of the 2 by 2 determinant. A11, A22 minus A21, A12. This is the general idea of a 2 by 2 determinant. Examples are, this is one example, it is another example. So this is a determinant which is called the determinant of a matrix of order 2. Which is called this determinant A11, A12, A22, A21, A22 is called is a determinant. Is a determinant of a matrix. Determinant of a matrix of order 2. Determinant of a matrix of order 2. This is called the determinant of a matrix of order 2. It can be expressed like that. Is a determinant of a matrix of order 2. Next, I am going to introduce a determinant of a matrix of order 3. Determinant of a matrix of order 3 by 3. Determinant of a matrix of order 3 by 3. Determinant of a matrix of order 3 by 3. Suppose A is a matrix of order 3, that is A11, A12, A13, A21, A22, A23, A31, A32, A33. This is a 3 by 3 matrix. The determinant of this 3 by 3 matrix is determinant A equal to determinant A11, A12, A13, A21, A22, A23, A31, A32, A33. This is the determinant of order 3 by 3. See, this determinant is associated with a real number because it is also having a solution. We can simplify this determinant. How? We will see. This determinant can be simplified using any row or any column. This determinant is simplified using first row or second row or third row, or it can be simplified using first column, second column or third column also. Now I am going to simplify this determinant A by using row 1, first row, expanding the determinant using first row, simplifying the expanding expanding determinant A by using R1 elements first row elements I am going to use to simplify the determinant. That is A11 into, you just eliminate the row containing A11 and column containing A11. You just eliminate the column and row, first row and first column. If you eliminate it, you will get a small determinant of order 2 by 2, A22, A23, A32, A33. Usually, second element is using minus symbol and A12 into, like that you eliminate the column containing A12 and row containing A12. You just have a small determinant A21, A23, A31, A3. Next, first element plus, next minus expansion. After that it is plus A13 into the column containing A13 and row containing A13 is to be eliminated, and you will get a small determinant A21, A22, A31, A32. So this is the expansion of this determinant. After that, you can simplify A11 into this multiplication of these two elements. That is A11 into A22, A23, A22, A33 minus A32, A23 minus A12 into this one. You just multiply the first by A21, A33 minus A31, A23 plus A13 into, similarly A21, A32 minus A31, A2. Like that, you will expand the determinant, you will simplify, and you will get, after simplification, you will get a number. Like that, a 3 by 3 determinant can be expanded. How I get the sign here, plus, minus, and plus? How I get the sign for the entire 9 elements, we will see one by one. That is, there is a rule. You just remember the expansion. Now, how to find out the sign of the number elements of using expansion? Well, while you are using expansion, finding the value of the determinant, how the sign of the numbers will be determined. For that, there is a general idea. In the 3 by 3 determinant, any determinant, there is an element of order Aij, ith row jth column element. Aij means ith row jth column element. Can be the sign of the ith row jth column element is to be determined minus 1 power I plus j, minus 1 power I plus j. This is the sign of the ith row jth column element. Minus 1 is the base. Power will be the number of rows and number of columns will be added, and we will get, if it is ith row jth column I and j addition, or if the addition of I and j is odd, there is a minus symbol. If the addition of I and j is even, you get a plus symbol, because you know minus 1 power 3 is minus, minus 1 power 4 is plus, like that. Minus 1 power 2 even, plus, minus 1 power 5 odd, minus. So minus 1 power odd powers are minus, minus 1 power even powers are plus. We will see one by one. Ith row jth column element is, you don't know where, what is I, what is j, but minus 1 power I plus j is the rule. First element A11. The symbol for A11, sign of the A11 element is minus 1 power 1 plus 1. Minus 1 power 1 plus 1 is minus 1 power 2 even. Therefore, it is plus symbol. Therefore, here you have plus. Next, A12. A12 is minus 1 power 1 plus 2. That is minus 1 power 3 odd. It is minus. Therefore, you have minus. Therefore, under the expansion, you should use minus for this element. Next, A13 is equal to minus 1 power 1 plus 3. It is 1 plus 3 is 4, even. Minus 1 plus minus 1 power 4, it is even plus. Like that, you have to decide the sign of the element. Next, A21 is minus 1 power 2 plus 1, 3, odd, minus. Therefore, this is minus. Next, minus 1 power A21, A22. A22 is minus 1 power 2 plus 2, even. 2 plus 2 is 4, therefore plus. Therefore, this is plus. Next, A23. Sign of the element A23 is minus 1 power 2 plus 3, minus 1 power 5, odd, therefore minus. Next, A31, minus 1 power 3 plus 1, even, this is plus, therefore this is plus. And also, this is the rule, you remember the rule. Next, A31, after A32, the A32 is minus 1 power 3 plus 2. It is again odd number, therefore minus. Finally, A33 is minus 1 power 3 plus 3, even, that is plus. So, these are the signs of the number of the 9 elements. Using this rule, we are deciding the sign. 4 coordinates and middle you have plus. The rest of the 4 pluses are minus. That is plus, minus, plus. See, if the odd places are minus, even places are plus. That's all. So using this idea, we can expand a TBT determinant using any row or any column. You can, if you expanding the first row elements, plus, minus, plus is the symbol fact. If you expand it through the second row column, minus, plus, minus should be the sign of the product element. So this is the method of expanding a TBT matrix using this idea. I am going to do one example. You will see determinant of a matrix of order 3 by 3. So consider a matrix. Determinant A is 3, minus 1, 2, 1, 4, minus 1, 3, 0, 5. See, I am going to find out the value of this determinant using the first row element. That is, determinant A equal to 3 into the column eliminating 3 and row containing 3. Eliminating 3, first row, first column, you get 4 minus 1, 0, 5. Next, you should have minus symbol because on the expansion you will get minus. Already there is minus 1 here, therefore you get minus 1 into eliminating second column and first row. Second column, first row. 1 minus 1, 3, 5. 1 minus 1, 3, 5. Next plus 2 into the column, third row and third column and first row. Eliminating first row and third column, 1, 4, 0, 4. So 1, 4, 3, 0. That's all. Expanding 3 into 4, 5 are 20. Minus into 0, 0. 0 into minus 1 is 0. Minus into minus, plus 1 into 5, 1 is 5. Minus of 3 into minus 1 is minus 3. Plus 2 into 1 into 0, 0, minus 3 fourths are 12. 3 fourths are 12. That is 3 into 20, 60, plus 1 into 5 minus or minus plus 3, 5 plus 3, plus 2 into minus 12. There is 3 into 20. So 20 minus 0 is 20, so 3 20s are 60, plus 5 plus 1 is 5 plus 3, 8 into 1 is 8, minus 2 12s are 24. 68 minus 24, 8 minus 4, 4, 6 minus 2, 44. So your answer for this determinant value is 44. That's all about the expansion of this matrix. So like that, a 3 by 3 determinant can be expanded using the idea of expanding any row or any column. You can use using these symbols of the elements. Okay, and I will stop here and I will continue in the next video. Thank you.